So in problem set 10, we're going to go over response to selection, um, both on a just per generation and also an annual response to selection. So there's three problems here, and we're going to work through the first problem. So you've got a breeder using 4 stallions and 20 females. The selected stallions are going to be used for 2 breeding seasons. Half of the stallions are 2 years old. The other half are 4 years old whenever their progeny are born. All right. Um, breeder is going to select the best 2 of 10 stallions. So I give you the intensity value, and we'll do that for each problem. So that's a 1.270 based on speed index. Mares are going to be used for 2 seasons, no selection. So all 10 mares that are produced are needed each season, therefore intensity will be 0. Mares are 2 years old and 4 years old when their progeny are born, and they are going to become highly inbred fast, but we're not going to worry about that for this example. So the first question is, what is the phenotypic standard deviation if the heritability is 0.20 and the additive genetic variation is 45? So remember, your variance in your standard deviation is measuring the spread, how different these animals are for a particular trait. So, and there's advanced statistical analyses that actually calculates the additive genetic variation, then subsequent heritability based on pedigree analysis and some other things. So, which is why we record performance information on animals. So on this first one, your heritability is equal to the additive genetic variance divided by the phenotypic variance. So I've got to find the phenotypic variance first before I can find the phenotypic standard deviation. So all I'm going to do is I'm going to take 0.20, that's my heritability. That's going to be equal to 45, which is my additive genetic variation, divided by, see if it'll let me do it here, sigma squared p. Okay, that is my phenotypic phenotypic variance. All right, and so this is going to be equal to, one second, let me fix this. That will be equal to 225. All right, so if I do 45 divided by 0.2, I'm going to get 225. That's how I did that. I just basically moved this over to here, and then this 0.2 gets moved over here, and then I end up with 225. All right, so now what do I do? Well, all I have to do now is just take the square root of this. All right, so if I do the square root of 225, that's going to be equal to 15. And 15 is my phenotypic standard deviation. All right, so I'm going to take this. Okay. And that's what you do on A. Okay. Final answer. What will be the male, female, and average generation interval in this herd? So I'm going to find it for the males and for the females. So my LM is going to be equal to 2 because they're 2 years old when their first progeny are born, and then subsequently 4 years old when their second progeny are born. And I've just got 2 groups, so I'm going to divide that by 2. If there was 3 groups of where I was having 2, 4, and 6-year-olds, then that would be 2 plus 4 plus 6 divided by 3. But since I've only got 2 groups, 2 years old at 4 years old, I just divide that by 2. And so that is 3 years of age on average. I do the same thing for the females, so that's denoted as LF. Same thing, 2 plus 4 divided by 2, and that equals 3 years of age. All right. So my response to selection, let's do the overall generation interval. So my overall generation interval, I take the average of these two, which is 3 plus 3. divided by 2, which is still just 3. All right, but in other examples, this is not going to be 3 and 3. This might be a 2 and a 4, or a 1.5 and a 2.5, or something like that. All right. So what is the response to selection, breeding value superiority for the males and for the females? So we've got to find, we're going to find the overall intensity value first. All right, and from your notes, it'll let me do the I correctly. I'm going to do IM plus IF. I'm just going to take the average of the intensity for the females and the intensity for the males. And that's going to be, and I'm going to divide that by 2. I'm just going to take the average. That's going to be 1.27 from up here. I give you the intensity value for the males. And see, for the females, there is no selection, so my I is just 0. All right, and I'm going to divide that by 2. And so you get an intensity value of, apparently I didn't do it in my notes, 0.635. So my response to selection, that's just R equals I times my heritability, this sigma p, my phenotypic standard deviation. Right? And so to find this, we'll go down here. I'm just going to take R equals 0.635 times 0.20, because my heritability is right here. I give you that, times the phenotypic standard deviation, which is 15, and that's going to equal 1.905 units per generation. If I want the annual response to selection, then I will just do 1.905 divided by 3, because this is my generation interval here. And that is, 1 second, $0.635. Funny how that worked out. All right. So that is how you do these response to selection problems. And I'm going to put units on this per year. Now, because speed index is pretty much unitless, in subsequent problems, you would have, let me get rid of that one. You would have maybe like pounds per year if you were measuring growth and performance, or if you were measuring ribeye area, it might be square inches per year or something like that. So you can actually, usually you do have actual units on this.